Good afternoon, everyone, and then thanks for coming to present and also just to attend the session. And welcome to the on-site paper session 6. The title is Lifecycle, Performance, and Flexibility Tools. I'll be moderating this session. My name is Fayaz Ahmed. I'm an R&D engineer and EU project manager in R2M Solution. I'm also working on lots of EU projects that deals with building performance, sustainability, flexibility topics. So I'm very much interested to know more about your project and your presentations. I think in today's session we will know more about cutting-edge tools and methodology that somehow revolutionize how we can design, assess, and operate buildings. We will hear about some hybrid testing, some data-driven digital logbooks, and also a lot about flexibility solutions. So I think it's really interesting. And we have three insightful presentations in today's session. The presentation one is from METABUILDING Labs. The topic is related to the bridging physical and virtual testing of facades. The title of the presentation is Bridging Physical and Virtual Testing, a semi-virtual bench for assessing dynamic facade performance. The speaker, Calin Boje from Luxembourg Institute of Science and Technology. So we will follow this order. So this would be our first presentation of the session. For the second presentation, we have a presentation from BuildON project. The topic is around data-centric digital building logbook. The title of the presentation is Advancing Building Lifecycle Management, Data-Centric Digital Building Logbook of the BuildON project. And we have a speaker, Davide Madeddu from one team. And the final presentation of the session is going to be from CIASEM. Topic revolve around energy flexibility using some collaborative and smart agents. The title of the presentation is going to be Value Proposition for Enabling Collaborative Energy Flexibility with Smart Energy Management Systems. Speaker, we have Ala-Juusela from VTT Technical Research Center of Finland. So I think without utilizing any other further time, I can invite our first, or maybe just few information before we go to the presentations. That for each presentation we will have 15 minutes, and around 13 minutes, when 2 minutes are left, I can remind you about the time. And in the end, after every presentation, we can also take some questions if somebody has some questions. Maybe I will have some questions. So first let's welcome Calin. Calin Boje from Luxembourg Institute of Science and Technology to present his paper. So we have already.
So
please, Calin.
I will need to leave early, so maybe I must take a few questions within the 15 minutes.
It's okay. So once you finish your presentation, we can
Hi everyone, welcome. So I'm Calin Boje, I'm a researcher at least in Luxembourg. I've also done my PhD in Cardiff University on BIM, knowledge development and crowd simulation of how people evacuate buildings, and then I've worked in this for about 7.5 years now on a bunch of projects. And METABUILDING Labs is quite an important project where I've converged a lot of the ideas I've been researching over the years. And this will culminate somehow into the digital twin also of the testing facility that we developed as part of the METABUILDING Labs project. There's a few other publications. I think there's some links in the presentation, so at any point you can also download them. They're on ResearchGate, and they are on ResearchGate. You can find also the other publications we have on the project and other projects. So for today, METABUILDING Labs, I'll present a little bit what METABUILDING Labs is about. METABUILDING Labs is close to ending. Maybe you guys have heard about METABUILDING or the METABUILDING Association. These are also coming out of these projects. And in MetaBuilding Labs, we looked at testing facility. I'll show you what that looks like. So our presentation is a lot of other partners. I'm sorry, I don't have a slide introducing all the partners, but please have a look at the website. It's a very big project, around 40 partners, and very challenging to manage. But this is the work done by ourselves in LIST together with NOBATEK in France as a collaboration. So this is some of our outcomes. And so really the challenge of MetaBuilding Labs is that we want to enable innovative facade solutions, and we also want to have a network of testing facilities that are able to deliver the necessary regulation and certification for these innovative technologies, which is usually a challenge. And so that is why we call it bridging the physical and the virtual, because we have to use a lot of models. We have a lot of innovative solutions, innovative designs that are very complicated to assess. You need specific modeling techniques depending on the procedure you need to test, or if you want to characterize the thermal properties of the facade elements and so on, which imply a lot of energy modeling, maybe even data-driven approaches and so on. And there's piling sort of rules and regulations going from energy performance to sustainability assessment, which are becoming even more complicated to handle. So MetaBuilding Labs plans to, yes, there's a question from Antoine. So some of these slides are from Antoine in NOBATEK. So is it a race for innovation or for regulation? I suppose I have an open question there. But I'm trying just to see if I can find a slide on the O3 bed before I go any further. So I apologize for this. But this is what the testing facility looks like. Okay. This is one of a few, because we are building about 5 or 6 of these. This is the design. This is a physical building in Cardiff in Spain. This picture was taken almost 2 years ago now. I'm sorry, I don't have any new pictures at the moment, but it has changed a little bit. And what you see here in this structure is a specific testing facility with very strict air tightness, with very sophisticated sensing equipment. And we have their cells, okay? And on the top of these cells, on the external, so you see here, there's a little bridge connecting, is where you mount a new innovative facade element. So if you want to test any type of material, any type of insulation, maybe a new type of window, you address it to this, you construct it to this size, you mount it, and then we try to characterize it thermally, for example, or we try to, yes, depending on the types of sensors we need, to monitor the performance of this new facade element in controlled conditions. And so for this, we have a BIM model, we have a digital twin facility, and so on. But I will now go back a little bit. It's not only just for testing maybe an innovative solution, but it will also be used for existing products to see if they're really performing as they claim to perform. So in many cases, it's quite hard to characterize certain properties. So yes, this is also another sort of application to try to test and prove claims. This is urban canopy is a type of green wall that is one of the innovations as part of the project. There's a few more, but this is the example we've chosen to show you today. So this is basically using vegetation to try to absorb light, for example. And really the question is, how do you model this, for example, in energy modeling, and how can we characterize it? Because it has a different shape, because the leaves may change and so on. And so, yes, what is it a good system for innovation? How do we characterize it? What are the impacts on comfort and cooling loads maybe, or heating? And there are really no standards to describe something that is very complex like this. Okay. So this is the O3 bed. It's a one-to-one scale testing, specific size. It is quite large. It is replicable. It's timber-based construction. The idea is that the design is replicated in different countries, and I believe I do have a map at some point to show you. Maybe a little bit after. Okay. So more, let's say, more as a testing service. So the O3 bed as a testing service. We call the O3 bed the testing facility for open source, open data, and open analysis of the testbed. We do an initial analysis. There's experimental protocols depending on the facade element that we are testing. There will be some energy modeling involved, and then of course the actual installation of the product on the facade element can vary between 6 to 12 weeks. Then you get to characterize it based on the data, and then we estimate a testing period and cost, let's say. So this is kind of going to the market with the MetaBuilding Association. And try to streamline it a little bit. Then at the bottom you see the BIM model and the server. I'm a bit confused with that. Oh, I'm not sure if this is the right, these are the right slides, I'm afraid. But it's okay, I will adapt. Yes. So I think I had a map at some point. Here there's a lot more slides actually, so.
That's the only slide uploaded.
No, I think I sent you something maybe yesterday on an email. I don't know if but okay, it's fine. So the point is that the sensor data is being managed by one of the systems. It's a BEM server. It's one of NOBATEK's products from a previous project, where we store all the sensor data time series and from all the sensors at the facility level. And then there's kind of in parallel or semi-manually checking of the data, cleaning up the data, and of course the extraction of the characterization factors for the thermal characterization factors, for example. And this can also be done by Python, with different Python scripts, or with Energy Plus, and so on. And then the next step of this, of course, we also have on the right here you see the more streamlined version of the platform as part of the digital twin. This is what we're developing in List. And what you see there is not the O3 bed, but it's one of the pilot buildings where we test the new facade element. So we kind of characterize the local facade element here, and then we try to test what happens if we install the new facade element into a real home, and to see how that behaves. And this is where we call the sort of more dynamic energy modeling. And we pretend we change either the windows or the entire walls of the building, and we can see there in the colors you see the energy intensity for cooling or heating of different spaces in the building. So you kind of, we want to offer this service to a small and medium enterprise that wants to test a new facade element. We can tell them, okay, you can test it with us, we can characterize it for you, and then we can also show you how will it perform on maybe a small residential home or maybe on a larger commercial building, to sort of show the potential of the regulated technologies. The problem really is that we don't have sort of a catalog of pilot buildings that are representative of different climates. So what we are at the step now where we wanted to build a bunch of simplified buildings of certain archetypes. So then at the second step, where we want to see where the client's element might function better, we simulate it in different types of buildings and different simulation and different weather conditions. And so we are generating this, and this is NOBATEK's work actually, so they're trying to generate this using grasshopper tools. And then we import this into our Energy Plus models to see. So this is just a bigger slide of what you saw previously. So this is the BIM model of one of the pilot buildings, and what you can see here actually is the cooling intensity and the heating intensity of the whole building throughout 1 year. And it is compared to a baseline. So that's why you see like two little columns for each month, where the baseline is assuming that the building is what the kind of clients have. And then if they use a new innovative facade product, here in this case, I think we changed the external walls of this house. We see an improvement in in this case, the cooling intensity stays kind of the same, but we see an improvement in the heating intensity throughout here. And this is, it's appearing in red because we can also look at the spatial level, and in this case it's red because there is an overheating experienced here. This is based in South, and there is a bit just to give you an idea of what you can see and you can scale. So then I'm reaching conclusions now. So in Meta Building Labs, we try to see how we can represent our physical components digitally. So sensor data with energy modeling, for example, a translation from 2D to 3D, we try to understand the context of the building, and going from expert models and expert research towards more sort of streamlined client manufacturing. And that's it, I think. So thank you very much. So any questions?
Thanks, Calin, for a nice presentation. And now we have a couple of minutes for questions. I don't know if somebody has some questions for Calin.
Yeah, I have a question about you have different pilots, okay, and different test beds, basically, and you are collecting so much data, and you expect to collect in the future much more data. Do you expect also that these data could be used for machine learning training or for a specific development of algorithms? And then, because I see also the presentation, the plenary, the first day, then is the concept of also open the possibility to experiment, and also the open the data.
Play into, yes. Very good question. It's difficult. I can answer you. It's quite complicated to answer.
Absolutely.
From the beginning, we said, yes, we wanted to be open source, open data, and so on. The problem is that the client is paying to have his element tested, so he doesn't really like you to share the data. So we have 1 or 2 papers discussing semantically. So our platform is a digital twin with ontologies and designing how we like deliberately silo the data. You know, the problem in the construction industry is they have silos of data and you want to merge them with semantic web ontologies. And in Meta Building, we kind of did that, but we deliberately siloed them to protect the client's data from the O3 data. Because if you look at the facility, maybe if I can quickly find one of the slides at least, the facility has multiple cells, right? And I think if you Google, you will find a paper where that is explained quite well. You could have one client buy this cell and another client buy that cell. There is also plan view in some of our articles where we show the planning from the top. And there is a guard zone, so there's sensors related to the facility as a whole, so that are shared, right? So the context of one test shares information with the other. So the external temperature and humidity, of course, should appear in both testing sessions. So we try to deliberately separate and protect the client's data from the data of the O3. So maybe the O3 data, you could say, could be shared if nobody has a problem with that, but we cannot really say that the client would like to have the data shared for research purposes, right? That's quite delicate. And if it's used for machine learning, yes, absolutely, you can. We are about to publish something with that. Based on time series data. It's one of my colleagues, but trying to look at time series data and to develop a surrogate model based on machine learning from that. That should come out in a few months. So if you give them an eye, maybe you will see it. Does that answer your question?
Yeah, absolutely.
Yeah, I have a question. I don't. You mentioned, what do you think the role of standardization in order to adopt this kind of procedures, right? Like you said, modeling, characterization. So this, what do you think? Is it like a precondition that having standardization to have more adoption?
Very hard to say. Actually, the person you see here has always had this question. That is one of our German partners. He has always been very rough on us on what does it mean to standardize, and how do we adopt and make sure that the standardized tests are followed and correctly implemented on these test beds. Very difficult question, because on the one hand, you want to standardize an element that is ready for mass manufacturing, right? But in this case, you may have a lot of innovative components that can fail, right? So may never make it to the market, maybe, or they change very quickly. So maybe you want to do the standardization a little bit after. So it's not fully certain how this will be handled by the test beds, and also it depends on type of test. Right? This facility cannot do a fire test, for example, or a wind test. Some of the other partners have a few other facilities where they test wind pressure on the elements and on windows, or fire. There was a Hungarian pilot that also built this, and they have a fire test that is separate from this facility. This one is better suited for thermal characterization. I think that is the key application at the moment. And the challenge of doing a standardized thermal characterization test, I believe there's an ISO, is that that you need to be able to have enough temperature difference between the inside of the cell and the outside of the cell to actually trigger a correct thermal characterization of your U values, for example, so that you can, and the conductivity and so on. So yes, that's also depending on what kind of weather conditions you have during the test. So that's why they give quite a long period to try and test it.
Thank you. All right. If anybody has question for Calin?
It's been a long day.
Because how much is the difference between if a company want to test
in-house or
yeah?
I don't know, to be honest, but maybe I forgot to mention there's a lot of things, but this is more suited for smaller companies. Bigger companies probably they just pay their own, they have their own things. But one of the ideas here is to also facilitate small and medium enterprises. Okay. Yes.
Also, they can find in the MetaBuilding network partners that maybe can provide some layers that the manufacturers developing their product don't have, insulation, or they don't focus on it. So they can find the product in the network, and then they can assemble and test.
Sort of a cooperative
yes,
work.
yes,
yeah.
And flexible and quick. That's not they will not reach the level of the official standardized test benches, but at least get the result more quickly.
Yeah.
Okay, then thank you very much. Yeah, for your presentation.
Please excuse me, but I do need to leave. Please search me, and if you have any more questions.
I will stay here. I can stay.
And Sylvain is here to answer all your other questions.
Thanks. And now we can move to the second presentation of the session. It's come from the BuildON project. And the title of the presentation is Advancing Building Lifecycle Management, Data-Centric Digital Building Logbook of the BuildON project. So yeah, let's hear from Davide and Madeddu about his presentation. So.
Yeah, because we tested
before.
Sure.
Sorry.
Yeah, okay. This is our development in BuildON. We are one team. One team is a company based here in Milan. We have our main business is to do consultancy with companies in construction, from engineering, design, and also construction company, but also in each field, not only in construction but also in manufacturing and GIS. Here in Milan, we do that, and our research and innovation team is working also in a European project to transpose all this research also for our customers. There's also why I ask before these questions, because we have companies interested in testing. Yeah, BuildON project is a now in the middle of the project, and the main goal of the project is to give to the customers a sort of tool set where there is inside digital twins, building logbook, and different services that work for brings all the data in the sensors of the building. There's also a SRI component that maybe you see in the other sections yesterday or also today. And there is is mostly about development of software, development of these kind of services. And the idea finally is to offer a sort of a toolbox that can be used in the homes, not only for the designers, but directly for the end users. There are specific applications for the end users to control HVAC, luminance, or everything inside the indoor air quality, obviously, inside the building. And our development in the project is specific for the digital logbook and the digital twin. You see at the end of the presentation also our vision about these two components that for us is really completely interrelated together, really linked. I don't know if you are already used to about the logbooks. I think it's something that, in the European projects is about, just to not skip the slides. The projects have obviously different building types. We have 5 buildings in different, there are not only residential, but there are office building, commercial building, and also a kindergarten in different parts of Europe. Another main idea is to build also the concept of a building as a service. Is something that is sounding in the last years, because we know that it's difficult to implement these kind of services and also to sell to the people, because there's a problem of GDPR, problem of security, problem also to digital literacy about the people that have to use that. And then I think to sell this to the people is as a sort of a service, like other services like Netflix and other things. Another important thing is that there are a framework that is based, for example, with ontologies, graph databases, knowledge graphs, and all the data is brought together in the repository. And then one of the main services that will be used for the digital logbook, are collected together and seen in the logbook. What is the logbook? The logbook appeared in the European directive about building performance a long time ago. And the idea is to have all the data together in one tool, in one service. Our vision is summarized in this image. It's a sort of a flight data recorder. As you know, every flight, every aeroplane have this database, this storage that says everything about the flight. Okay, and basically the logbook is the same. It's a sort of flight recorder for the buildings. We store everything in the entire life cycle of the building. Every changing about maintenance, big changes, or also smaller, just changing a lamp, for example. Everything stored in one point. It's not new, because as you know, different countries have, for example, in Italy is fascicolo del fabbricato, is standardized, but it's not more used, and mainly is paper, because it's poured before. And the idea is to have all this data, obviously, stored in one point, but also digital, because is what we want. It's basically something that is really near as a concept, like, for example, a common data environment that when you design a building, then it's something that we see that we can pick the data on the common data environment and transport in the digital logbook, for example. And there is a different kind of data. There is static data. There's documents, drawings, document specification, everything that is born basically when you build the building. Okay, this is valid for building, but also infrastructure. Everything could be inside the logbook. Every construction. And now there is also the dynamic interactive data, because all the data brings from sensors. Every data that can be from, for example, if we can think a logbook of this building could be all the data brings also for the people that are moving inside the building, maybe in unmized site, but which enter, go back, and so on. This is all dynamic interactive data that could be stored inside the logbook. But the important thing is that also that we want to store the data, but this data need to be updated. One thing that is not so much studied is also how to maintain this data in the years, because we are speaking also in terms of 10, 20 years, basically the duration of the building life. Yeah, as I said before, data that could be ownership documents, property tax, insurance, everything that maybe everyone can have in the house. When I go to the designer, just to say, I want to renovate, I need these kind of documents to the building permit or the drawings or everything. Then it is nothing really special. It's just one point where we can store everything. And another big point is also that is why the European Commission in the Building Directive pointed the digital logbook, because there is the energy certificates like APC. There is also a sort of extent of the digital logbook in the terms of a renovation passport, because basically it's something that in logbook you storage, and you have historically the story of the building, and then the passport brings this data, and you can plan what to do with your building. I want to go a little faster on that, because as you know, the big challenge is that when you construct your building, there's the as-built data, and there is the uncovered gap, because it's something that we can be able to track everything until the construction. BAM, for example, is very special for that, and we say and we sell the BAM as something that you can use this data after for the maintenance, but this is difficult to make it really works. And then the logbook is also something that we can use to reduce this gap. And to do that, the problem is that we have the ability to connect to different kind of data, different kinds of sources, obviously, because until the build is completed, then you have to connect to BMS, you have to connect, for example, with the municipality data, or everything that you have to connect with the external sources, and we needed to normalize this data. Typically, there is also another problem that for the new buildings, especially for the last years of buildings, like for example, 4 to 5 years, is more common than before to do in BAM, not everywhere, but it's something that is starting to be sounding to the market to use BIM. But the problem is that this is a special situation. More often you have just CAD drawings, okay, and nothing else. Then the problem is also that everything there is as a source, like BIM model. Now that there is a sort of top-down workflow, we say that is that a first phase of you have to parse the data in the BIM model, for example, converting in IFC, converting from the IFC to the database, because you need to storage all these things. This is a traditional workflow. Is we see also in most of the traditional European projects. This is something that brings the BIM, convert, and storage in the database. Now it's time to use a sort of a bottom-up workflow. Because if the BIM contains data from the building, what we need to convert is inside the BIM. Okay, the only problem is to ask to the BIM and get what you want. Okay, and then there is a new software systems that allow to connect to the data model of the BIM and use different APIs endpoints that can ask directly to the BIM model and to give this data in parallel way to the specific user, the specific data that you need. Because the problem is to convert, for example, the entire building. But if you have a user that is inside this room, I just need the data for this room. I don't need all the model. Then it's a problem of data transition, data storage, and everything. Then the bottom-up workflow is that we can be able to ask directly just the data of this room, not the entire system, and also to not convert to have 2 copies. BIM model in the database, and then other BIM models are copies. This is a completely counter tendency about having just 1 copy. This is the common data environment, just 1 copy for everything. Okay. And then we use the concept of the digital logbook around this, and we create different type of functionalities. Obviously, user role management, because the logbook need to be able to be used for the users, like the end user, the people that are inhabitants, the designers, but also municipality and so on. There is data management of the building, a 3D viewer. And finally, also a sort of a digital twin dashboard, because if we are working on the building, we need also to see directly what we are asking to the logbook. Yeah, this is a BuildON logbook architecture. Basically, we connect our work is from this side to the right. The left part is done by other partners that work for the endpoints, for the sensors, all the data of the buildings and so on. But we work to convert that with GraphQL queries and to filter that to visualize directly in the logbook. These are the first version of the logbook after 2 years of work. Excuse me for because I just screenshot this a video, but I would prefer to to be more fast. But if you see in the BuildON project, you can see some of that. There is a role definition where you can say, for example, the companies that works in the building, for example, for maintenance, your architect, everyone that works in the building with associated users. And this is the logbook. That basically is a sort of database with some interfaces, okay? Categorized data in building identity, where is the building, weather data, general dimension, and the others like sustainability data, energy, how much I consume, how much I produce. And it's nothing new, nothing exceptional about what kind of data we have inside. And we create this sort of interface. But what is important for us, and what we work at so much in these 2 years of the work, is that we create first interfaces that are not more sophisticated, because in the years of exploding the use of language models, AI interfaces, okay, basically you don't need an interface, because basically now you can ask, give me that for that in this way, okay? Then we don't need an interface, because we can ask directly to show something in some format. Then the development of the interface is in some way stopped, because we see that, okay, why not implement directly a sort of chat box, maybe directly by voice, to ask directly to the logbook to find something, instead to have a sort of a HTML page. Okay, this is the first point. and it is in development. The second part is to filter directly the BIM model to give all the information in tailored for my use case, for my use persona. Okay, and to do that, also we focus more on the part of the data than to normalize all the data. And another important thing is that we are created something that is parametric. Then basically, this is a logbook that works for BuildON pilots, because we stored the specific parameters that you can find in the BIM model, and also, sensors or everything. But you can change with everything can be customized for every type of the work. Okay, you can, for example, change and replace some parameters with others that are maybe specific for infrastructure, like a bridge, like I don't know, a train station or everything. And it's just to be stored. And the next phase is also to connect this with ontologies and to have a graph vision of the database in some way. And another thing that I don't put so much pressure is that differently to the other logbooks and the other approach, our approach is to that we don't parse the building, we don't parse the BIM model, then we don't pick the IFC and read each line of the IFC and storage directly to the database, but we ask directly the IFC. Then we have just the file and nothing else. Okay, and we use the database just to store the link to these elements. Another point really interesting is that in some way the digital logbook remain a sort of a repository that is completely linked with digital twin, because a digital twin, you visualize the building and the data that are linked, you can be directly stored in the logbook. And every time we can go back and forth with these two functionalities. And in the middle, there's also the renovation passport. There is the next part of the logbook. Then if we have the data, we want to have a renovation, we can just put a plan inside the passport, but using the data in the logbook. And these are the development in this moment. We have also 2 years of development, then we have other things, and we are also working to go forward, for example, to use also the logbook to a sort of that we can call write back. Like, for example, if you have the logbook with data of your building 10 years ago, and you are going to renovate this building, we want to download, for example, your IFC file or Revit file with all this data updated. It's like as-built updated at the time that you are requesting. This is much important because if you go to your designer to do a renovation, you need this data, and then we recollect all this data. Yeah, it's the end.
Thank you, Davide. Very nice, interesting, and relevant topic presentation for the last 2 days. We hear a lot about SRI, also cities. Session on the first day, we talk a lot about data, putting things together. Yeah, it's very interesting, relevant presentation. I have some questions, but before I leave, to the audience, if you have any questions for Davide, please. Sure.
Yeah, that is really a wonderful thing would be, because as a single-family house from 1968, I'm missing all that information. That would be wonderful, but it's a lot of work to get all that information from the existing buildings. But for the new buildings, definitely, I think that's a wonderful idea.
Yeah, because also I think just because I think I'm not so sure about this fact, but I keep hearing in these sessions about 90% of the buildings, they will still exist in 2050. So a lot of these buildings, they already exist. So how
This is a good time to start with this.
How is this? Does it make a lot of difficult if it's a new building to do this, what you do, or also with the existing ones?
Yeah, we are in the point that in the startup of using BIM for new construction is the natural progression, because you have BIM model, okay, maybe there are differences in BIM model because there are some BIM models that are not so detailed, or maybe there is also the problem that, as you know, when you work in digital, the digital need to be very precise, very organized. And then there is another step in between where the data need to be organized in some way. This is something that is not completely in the slides, but it is another problem. But we can, basically. Then for the new buildings in BIM, is natural. Brings the data, you ask directly the BIM model, and then you can augment the data of the BIM model for those things. There is a big problem of the construction that is CAD, just drawings in CAD drawings. And there is a lot of research where you can create a sort of a 2.5D. It's not 3D, it's not BIM, but it's something that can be used, for example, for energy modeling, because you know, it's more simplified in some way, the model for energy. And now we are working on the part that also from CAD you can bring this data inside. What we are studying in another project that we are working, and we start in the next weeks, basically. Another problem that we want, it is a sort of exploitation of the BuildON logbook, is that we want to use language models to bring the data that are stored in PDFs or images or everything, to put this data directly inside the database. This is another point. Is very promising, because in just 1 year we have a sort of things that we don't know 1 year ago. Then this is very promising. And for example, for very old buildings, maybe the problem could be just to have the drawings, but all the data can be stored using AI. This is another point that is very promising. And also, the second point that I see also in the presentation, for example, for the Digital Twins Association, is that you can start with what you have. Basically, you don't have start for the top, but if you have a small data, you can start for that, and then augment day by day. This is the same that when you apply BIM, for example, BIM for renovation, that you know that you don't have to have a point cloud survey of all the buildings, but you do this only when you renovate the building, because it's in this point that you need these things. Then I think that the most promising thing is that now the artificial intelligence will help a lot, not in terms of reconstruct 3D point clouds, but in the document part is very, very promising, and there is a lot of explosion of functionalities.
I think especially interfacing with this huge amount of data, I think manually it's going to be a challenge. So there's a huge potential using AI and this kind of tools to just go out and get insights from all the data.
Yes,
that's what I also suggested to Eduardo Loscos about this, because there's something that has been discussed. I didn't want to open that discussion here, the interoperability.
Yeah.
if AI could help in that, but he had a little bit hesitation for that.
So yeah, I think we can try to wrap up. So just I don't know. I have one question. I don't know if about this topic of SRI because okay, I see if you have so much data then the potential is infinite. Like you can do a lot of stuff with this data. But yesterday's session on SRI, there was a lot of discussion about about the availability of data, but also the expertise in the assessment. Do you think this kind of repository data could help measuring this kind of score for SRI?
Absolutely.
Automate this stuff?
Absolutely, yeah. I think that, we put the digital twin as example, maybe major example that you have data and you explore the data, have a journey inside the buildings, for example, as a digital twin. But for sure, it's something like a hamburger part, okay, where there are different layers of data and also the services. And there is a Logbook, SRI, there is also the renovation passport, but also the digital twin. We think that is something that can stack together and maybe tailored with the different fields. But the major problem of SRI is that, okay, first we need data, but second is, how to assess is not completely clear, but I think that is just a point that is a new concept. As for example, the first time for the certification of the buildings is the same thing, but they source from the same part. But there's also, for example, another opportunity is, for example, that all this data could be connected, for example, with the GIS systems that you can enlarge also the things, but the concepts are the same, basically.
Thank you. I think, we need to move to another presentation, the final presentation. So I just start.
But just for part of the presentation. Thank you. Yes, so hello everybody. I'm Ala-Juusela from VTT Finland, senior scientist in a team of energy resilient buildings and districts. But today my presentation is about a national project about the smart management of energy systems in different levels. And this is a national ongoing project, so we've only been working for 1 year. And my presentation is partly about the project and partly about the value proposition that we are developing there for a business model that will be presented or developed there. It's not a real business model, but an optional or scientific model, maybe more likely. So first about the project. It's about intelligent agents for smart energy management. And as a background, as we all know, the energy use doesn't match the production, or especially the renewable production, because that is varying a lot in real time. And then there are volatile energy costs and CO2 emissions can be managed all the time. There's a flexibility that is come often in these meetings. And then the energy potential or the flexibility potential of the buildings or real estates haven't been taken into account so much yet, or especially on the level of energy markets. And the digital and AI-based solutions is growing, and there's a lot of potential also financially. But the question in this project has been that how can we enable fair, collaborative, and flexible energy management in real estate to decrease the energy costs and cost variation and also CO2 emissions. Okay. It's a little bit slow in reaction.
It's a bit slow, yeah, sorry.
Yeah. Okay, anyway, our mission in this project totally is to co-innovate and demonstrate a value co-creation driven, highly automated multi-agent system, which enables energy flexibility flow between energy users, energy distributors, and energy producers by energy or flexibility markets, and also finding a fair remuneration between the involved stakeholders. Yes, it's a cooperation with different partners, so VTT and several companies that present different stakeholders in this value chain. And there also, the first thing that we did was we developed some use cases that to find out the different options for this solution. Yes, and as I explained, there are 14 Finnish companies. Some of them are involved deeply in the development work, and some of them are there to provide like demonstration options and buildings, yeah. But also some are there, like Oulu Energia, Vantaa Energia. These are the energy TSO operators who want to also learn about how it can be done. Almost again, so, yeah. And what we are expecting to receive after 3 years. So now we are 1 year, about 1 year in the project, and make a multi-agent system, which is providing this potential for the collaborative energy flexibility. But also one part of the work is the scalable business models that we are doing here in this task of the project, part of the project. And there are also some user interaction, user interfaces, and also some different architectures and using artificial intelligence and edge computing. And these are also developed by the project partners. And also improve this interoperability again, and the data management. And also to receive the seamless flow of flexibility towards the multiple markets. We will have some prototypes and demonstrations and evaluation of the decreased energy costs and CO2 emissions in these different sites. There are several different sites, but I think there are some of them maybe mentioned here. Yeah, and all this that is done is all open source contributions, or at least that is the goal. And hopefully to get some solutions that are as much scalable as potential as possible, and then do some impact analysis. Prepare, of course, as PTT is involved, some scientific publications. Yeah, and as demonstrations, we have some apartment buildings. We have an elderly care building, or elderly care buildings, and office buildings and supermarkets. And then there's an office and factory combination there in Oulu, which is in northern Finland. And these different demonstrations are a little bit here and there in Finland. The data that's collected from demonstration is then extrapolated for scalability and the impact analysis. And there are the project consortium has like a potential to reach over 3,000 buildings globally, because they have also clients everywhere. And that was like about the project in general. I thought it's relevant for this conference, because there's a lot about this digital and flexibility. And if you have questions about the project in general, you can contact our project manager Daniel Pakkala, because we don't have any website so far. Yeah. Yeah. And then we come to the part of my expertise, which is the value proposition. And this is related to the scalable business models that we were supposed to, which we are supposed to develop in this project. As I mentioned, the first step in the project was to develop these three different use cases. And I'm just going to explain very shortly what they are. The use case first is related to how the site or facility manager can optimize the energy costs and CO2 emissions by managing the flexible elements like energy use or local production or storage in relation to the energy prices and availability. And this could, for instance, include some weather-dependent energy use patterns also. And in this use case, the site owners and users are in central role because they can decide how they can, for instance, what investments are done in the site, or also how much flexibility they can offer. The second use case is realized through sector integration, like sector heating, cooling networks or storage operation. And the aims are similar as in use case one, but also in addition, like they might want to avoid energy grids congestion or a reduction of renewable energy curtailments. And this is realized in cooperation with the heating cooling companies, DSOs, site operators, and etc. And the third use case is larger. It's related to available flexibility potentials coming from the site energy management agents. So collecting that use case first, one thing. And then in this use case, these flexibilities are aggregated towards energy and flexibility markets. And the aim is to form optimal market offers. And these main drivers are increased market offers and increased competition and market liquidity, and also the fair remuneration for flexibility providers. And this idea is that this would be the win-win situation for flexibility buyers and end customers that are providing this flexibility. There's why I went through all those use cases is that there are a lot of different stakeholders involved in this process. These are the agents, these are the digital and AI things that are used for the management. And then there are different stakeholders that are involved in different agents. And the first thing that we needed to do in this team is which of these stakeholders are customers and which of them are the business owners. Because in the business model development, you have to first define which is the most relevant customer or customer segments, and then recognize the needs of the customers and what the products are you are able to offer. And therefore you can end up to this value proposition. And after that, to get the business model, you go through relevant other aspects. And for this you can use the business model canvas, which is quite widely used, and this value proposition canvas. And then you can also do some test or SWOT modeling if you want. And this is the business model canvas, and we addressed like the first steps on the customers and then on the products. Then in the future we will look at the other parts of that. And we started with the value proposition canvas, which addresses the customer segments and the value proposition. And this we did by workshop with the project partners and using this Microsoft whiteboard tool. So these project partners are partly the stakeholders that are mentioned in there, partly they are the product or service providers. And then it was a little bit challenging that they tried to take a role of a hypothetical service provider, so that it first was a little bit difficult to get the discussion ongoing, but when they realized, when they got to the flow, then it went more smoothly. These are the typical questions that you ask for the value proposition. Who is the customer? What are his jobs? What is the customer trying to do in life or business? What would make the customer happy? What is annoying? What is preventing the customer of doing the job? What can you offer to help in fulfilling the needs and solving the problems? And then what are the products and services that will help the customer to get his job done? But very first we needed to start the question, who is the owner of the business model? Who will provide the value proposition to the customer? Because there was so many stakeholders recognized. And then we ended up that most of those are key partners, and the business model owner is the facility management service provider or the energy management service provider. And now then we started to look then who are the customers for this kind of business model. And this is like the business model, the Microsoft whiteboard that we used for this. And then we ended up to have to decide that it would be the site or facility owner who is the main customer. And then it's also important in this case to recognize what is the customer's like wishes and hopes, because that's what his job is, basically. And then we went through the customer gains, pains, jobs, and so on. And also through all this gain creators, pain relievers, product and services. And then you may see in different colors that we also have, that we had additional questions to ourselves that we need to find out to create the business model. But after having gone through all those questions and discussing a lot, we ended up with a value proposition, which is like a hypothetical business model value proposition, is that the product, which is the automated energy management service, enables the building owners, which is the customer, and to optimize the energy costs, which is the job that the customer tries to do. And then additional values are that while minimizing CO2 emissions and ensuring the health and well-being of the building users, and also the health of the building structures. That was also very important. What else is it doing is reducing the risks. This is the pains that are reducing the risk and investments related to the complexity of the energy market and the prediction of different aspects of energy demand and availability. And then value is increasing property yield and share of controllable loads. And that would be unlike any other service available on the market. That is how far we got, and the next steps is then that we need to build on the business model canvas on what are the key partners, what are the key resources, where does the income come from, and so on. And actually now we are calculating what is the benefit for the customer, so the cost benefit for the customer, so that it's big enough for the customer to be willing to pay for the service. And that's all for me.
Thank you very much, Mia. Very interesting presentation. So now I'll open the floor for questions. I don't know if you have some questions. Please, this is the time. Yeah, so I can ask some question. But on this process now where you are, what was the most challenging part? Like, yeah, also this process of value proposition, matching a value proposition with the customer. So what were the main challenges you faced in this business, in this process?
Maybe the main challenge was to get the project partners in a new set of mind, like let's imagine something that doesn't exist now, that even us are not providing yet to anybody. So that was like the main challenging. But when they get to the flow, then it went really. They had a lot of new nice ideas, and they were nicely aligned also. So.
No, I think, yeah, I also have personal experience working on this kind of projects, because Atrium is also our main role is usually exploitation and business models development for the projects. And sometimes, yeah, you have more technical focused projects where, yeah, they're more focused on the technical research aspects and not so much on the exploitation part. But I think it's very interesting. Yeah. To make these research.
There were some of the partners were strictly on the technical development, but there were also some from like the management and customer relationship representatives. Very few.
But okay, so you're still not at this stage. But how do you validate once you draft your business model? How you validate it?
then we probably have some discussion with the partners that if this is something that they themselves could adopt. Because that was one of the discussions in the very beginning, that are we going to look at the one provider, service product provider, or is it an ecosystem business model? But yeah. But maybe we will end up in an ecosystem business model after all. It seems that this needs so many actors, different actors.
Definitely. Yeah. I don't know if anybody has a question. Yeah, so otherwise, yeah, that brings us to the end of our session, and I sincerely thanks Mia and Davide and Calin also for insightful presentations. I think, yeah, all the talks and discussions that we had highlights that convergence of these innovative technologies, yeah, makes buildings more sustainable and affordable in the future. So yeah, thanks for your time and attention. Yeah. Thank you. Yeah, enjoy. Have a safe trip back home. Yeah.